game's over. Well, there's like 3 minutes left, but Dixie's so far ahead. I don't even care who won, but it's kind of fun to watch. All right, okay, here we go. Find the value of each variable. Starting right here. What do you guys think it is? 76 degrees. And what do the three angles of a triangle add up to, you guys? 180. That's what we learned last time. So 66 plus 38 makes 104. And then you take 180 and minus 104, and you get 76 degrees. Good job. Okay? And then this one right here, in order to get B, you have to get A first. What is A? How do you get it? It's what? Add 30 to it? Well, no, 50 is this angle right out here. Well, actually, this angle and this angle add up to 180 because they make a straight line. Do you see that? So 180 minus 50 will give us what? 130, and so A is 130 degrees. And then B can be found by adding 130 and 32, and you get 162, and then 180 minus 162, because the three angles add up to 180, is 18. Did anybody get 18 for that one? Okay, so B is 18 degrees. Okay? So basically we learned last time, you guys, that three angles of a triangle add up to 180. We also learned that in this one right here, we learned a long time ago, linear pair of angles are supplementary, so they add up to 180. So all we had to do is minus 50 from 180 to get A. Okay, number 3, the measure of each angle of a triangle is x. X plus 15 and 2x minus 3, find the measure of each angle. How would we do that? Any ideas? Okay, and what would that equation say then? And how did you get 4x plus 12? Okay, so x plus 2x made us 4x, right, you guys? And 15 minus 3 made 12. And you know that the three angles have to add up to 180. So we get that equation now. Now we got to solve the equation. What would you do to solve that equation? Minus 12. We get 4x equals 168. Divide by 4. We get x equals what? 42. And that's x. Is that the answer to our question? We're supposed to find the measure of each angle. So what would this angle right here be? 42 degrees, because x is 42. What would this one be? 42 plus 15 is 57. And this one? 81. Because 2 times 42 is 82. Wait, 42 is 84, minus 3 is 81. Okay, good job. All right, I'm going to answer, are there any questions on last assignment? Okay, Bailey? Did everybody get the assignment? David, would you go open the door? It's kind of stuffy in here. 14 and 16? So it sounds like 16 for sure, but let's look at 14 first, and 16 and 22. We'll look at those three. Okay. Number 14. We have this triangle, and we have, by the way, this line's called an altitude. We'll be learning about that in a little while. And you have, this is a right angle. You have you need x and y, and that you have this as 33 degrees, and you have this as z degrees. And you're supposed to find x, y, and z. Guys, how many triangles do you see in this picture? There's not one, and there's not two. Where are they, Trey? So, yeah, there's this one right here, this one right here, and then you got the big one right there, right? Okay, so we got 3 triangles. And if you look at the big triangle, do we know 2 of the angles of the big triangle? Yeah, we do. Which 2 do we know? (33) and the right angle right up here, right? So the 33 and this whole right angle and this angle z are supposed to add up to 180. So we can add 90 plus 33 is 123 degrees, right? And then z, you take 180 minus 123 equals 57 degrees. So z equals 57 degrees. Okay. Can we use that to help us find one of those angles? Well, if this is 90 degrees and this is 57 degrees, we can find y now, can't we? Because we have a 90-degree angle plus a 57-degree angle, and those add up to 147 degrees. So if we take 180 minus 147, what does that make? 33 degrees. So we have y is 33 degrees. There's a couple ways we can get x, isn't there? What are the ways we can get x? Yeah, 33 minus 90, because these 2 angles add up to 90. So 90 minus 33 makes 57 degrees. So we have that as 57 degrees. Okay? I think some of you guys followed that really well. Good job. How many of you already had number 14 done and correct? Okay, good. All right, what's the other one? 16? All right. 16. What does it? It looks something like this. And you have this angle, this thing come down here, and you have z degrees, y degrees, 65 degrees, 51 degrees, and x degrees and x degrees. Since those are both x degrees, does that mean they're the same? Are they congruent? Yeah, and that means that this line right here is bisecting that angle. We'll be learning about that later on. Okay, but how many triangles do you see in that picture? 3 again, right? You got the 2 small ones on the right and left, and then the big one that contains both the small triangles, right? So which of the triangles do we have 2 of the angles? The big one. We have 51 and 65, and so this whole angle up here where these 2 x's are is our 3rd angle, right? So 51 plus 65 adds up to 116 degrees. Okay, right? Good. And Sarah just said, don't you have to divide it by 2 to get the 2 x's? You do. What's 116 divided by 2, you guys? It's what? 58 degrees. That would be right, because 50 plus 50 is 100, and 8 plus 8 is 16, right? So that's 58 degrees. That's 58 degrees. Could we find y and z now? We know this angle and this angle. Can we find y? 58 plus 51 makes 109 degrees, right? And 180 minus 109 makes 71 degrees. So this is 71 degrees. Since this is a straight line, could we go 180 minus 71 and get 109? So this one's 109. Right there. Okay. Yeah. Run it down real quick and then come back. Okay. Okay, 22 is the next one. Okay, 22. We have the measure of the angles of triangle are x plus 5, 3x plus 14, and x plus 11. Find the measure of each angle. That's kind of like the bell work problem, wasn't it? What do we know about three angles? What do they add up to? 180. So tell me what those angles are again. X plus 5 plus, what's the next one, you guys? Huh? 3x plus 14 plus x plus 11 equals 180. Is that it? And then we can shorten it kind of like Isaac did. He kind of did it in his head, though. X, 3x, and x makes how many? 5x. And 5 plus 14 plus 11 makes 30. And so we solve that equation, right? Minus 30. And we get 115 divided by 5, and we get 30. Yeah. Anybody else need to turn it into Miss Eves? Okay, go. Hurry. Wait, where are you going? No, come here. You don't have an assignment. Huh? Okay. So, here we go. We've got these. What are my three angles, you guys? How do I get them? 30. Okay, well, this is one angle, right? This is another angle. And this is another one, right? So one of my angles is 30 plus 5, which is 35 degrees. Another one of my angles is 3 times 30 plus 14. What's 3 times 30? 90 plus 14 is 104. And my last one is 30 plus 11, which is 41 degrees. Well, should add up to 180, right? I believe they do. Okay? All right, let's correct this assignment. That's the three. We found x by making that equation, and we found the three angles. All right, we're going to correct this. Okay, in geometry, there are three fundamental types of motions. The first one is a translation. Translation, all you do is slide. Chris, do you need a notebook? You need a notebook. Huh? Do you not have one in your? Just stay here. I'll get you a piece of paper. Okay. What was the question again?
Why don't they just say slide? Why have to give up complicated names for everybody?
That's the official word for it. Then use slide. Okay. So you can slide things. I want you guys to think about what are the other ways you can move things. Flip. Flip is another one. What's another way? What? Well, pushing is you're making it slide. You're making the object slide. So that's the same. What else? Huh? Drop. Um, and you know what? We're actually talking about on a plane. So drop probably wouldn't work. Rotate. That's another one. Okay? Those are the three. So reflection and rotation. So reflect means is another name for a flip. You flip a figure over. And then rotation is another name. Another name for this is a turn. You turn the figure around a fixed point. Okay, so those are the three ways we move things in geometry. Okay, are we done? Are we still writing that one? Okay. To demonstrate a translation. By the way, if I was talking about this red dot moving it to that red dot, so the whole figure moved in unison, okay, what would you describe to someone you're going to do? As far as mathematically, right here on the screen, using that grid right there, what would you say? How far would you slide it one way and another? Down 3, okay. 1, 2, 3. I'm going to move this thing too. And then what? To the right 5. 1, 2, 3, 4. 1, 2, 3, 4, 5, right? And then we would move that one over 5 too. And that's that. Okay, so that is a translation. We slide it. So that was a translation of 3 to the right, or 5 to the right, and down 3. Okay? A reflection usually has what we call a line of reflection. This red line is the line of reflection, and it's kind of like a mirror image. Okay? Usually, points are always perpendicular. If you draw a line from one point to its reflection, if I was to draw that line, it's a perpendicular line with the line of reflection, and this half is congruent to this half right there. So like from this point to this point, you have this as congruent to that, and then it's a perpendicular line. We could do the same with any point on here. You chose a point there, wherever it is over here that makes a 90-degree angle right there, okay? And so that would be a reflection. And then right here, a rotation usually has what we call a point of rotation. So right here is a point of rotation. This doesn't work very well for rotating, but you can see that this is the center of a circle, and if I rotated this point to this point, it would move along that circle right there. This point would move along the circle there. It would have a greater circle than this inside one right here, right? This point would be on a circle. It moved it to there. Do you see that? It's moving in a circular motion. We say it's rotating. Okay, any questions there? Okay, now, whenever we transform something or move it, Okay, these are called transformations, by the way. Whenever we transform something, we have a pre-image and an image right here. Okay? And we map the one thing onto the other. So what is B going to map to, you guys? E. And what's A going to map to? D. And what's C going to map to? F. And so we can move. So triangle ABC maps to triangle DEF. And if you guys notice, we wrote this in the form in the order of A, B, C. It really doesn't matter which order we write it in, but we went from A to B to C. So we have to go in that same order over here. So we got to start with the one that's an image of A. So what's the image of A? D. And then we went to B. So what's the image of B? E. So we had to go D, E, F in that order right there. Does that make sense? Okay. So moving this up right here, mapping triangle ABC to triangle DEF. And the order of the vertices indicates the corresponding points. So what does A correspond to? D. What does B correspond to? And C corresponds to F. Side AB, which is this side over here, corresponds to side DE. And side BC, which is this side over here, corresponds to EF. And AC corresponds to DF. And that's what that means. It corresponds means it's the one its image goes to. You got that, Mitchell and Trey? Fine if you guys sitting by each other as long as you are listening. Okay, so we did that mapping right there. Now, a mapping is called a transformation. Write that down. You need to know that word, transformation. All of these transformations are called isometries. What is an isometry again? Does anybody know? It says right here. I wrote it for you. An isometry does not change size or shape when moved. When you move a fixed object like a table, does it change shape? Or a chair? But what about a person? Does a person change shape when they move? Well, kind of. Well, it's not like they get fatter in that direction. They're the same, but their shape changes. Like if you have your knee up or your knee down, right? So that could change. You could count us as an isometry in a way. Just depends. What are some things that are not isometries that move? Jello. Huh? Water? Water definitely, yeah, good. That's a good one. What else? Snow? Yeah, you could change the shape of snow. Okay. How about a balloon when you blow it up? There's another one. Okay, you guys had some good ones right there. All right, so do you guys know how to map one transformation onto another? You know, a transformation, what are the three transformations? Let's see if you know them. Slide, flip, and turn. Slide, flip, and turn, or you can say translation, reflection, and rotation if you're Trey. He likes those big words. Okay? Too bad Jessica's not here. She would like this. All right. Lesson 5-3, page 201, 1 through 24 all, and number 26.